All right. Hey, everybody. Welcome to this workshop. So we're going to be going over visualizing hierarchical information. We're going to be doing this with D3 and Vue. Now, I've set up this workshop. It's up on GitHub. I will go ahead and put a link in the room here for you guys to check out. So if you want to follow along, please do. Otherwise, you can watch this at a later time, go over the workshop again. So without further ado, let's get started. Here is the GitHub repo. You can go over to here and run a checkout. You can either use yarn or npm to run this. So just run an install first, and then you can either run yarn dev or npm run dev, and that should open up the project. So let's go ahead and do that. This is Visual Studio Code. This is our project that's loaded in. Now, I already have installed all of the dependencies, so we can just go ahead and type in yarn dev. All right. We'll let that go. When that's done, then we'll be able to run through this thing. All right, so here we are. So when you run the project, you'll get this screen here, visualizing hierarchies. So you can go ahead and hit start to get started. It will give you the same information that we had in the GitHub README file. So if you are seeing this screen, then obviously you've done these instructions. All right, so a little bit about me. My name is John Snyder. I love to design. I discovered programming a while back. I loved it too. I learned Flash. I combined both my passions. It was the best feeling ever. And then Flash died out. I kind of felt a little bit lost. I learned JavaScript and a language called Hacks, which are both kind of, an open source kind of approach. I got married, got motivated, became a workaholic. This is all that I do now. I absolutely love it. And now I'm about 34. I have an awesome family, moved to Florida. And I am currently a developer and designer at OneDiscovery. So why this workshop? Over the last couple of years, I've developed a somewhat unhealthy obsession with visualizing data. As time went by, because I come from a designer background, after doing a lot of this, I started to realize how much these UX laws and data visualization had in common, and it was all I thought about. And the awesome people over at Vue.js, I'll give them a shout out. They were the ones that allowed me to do this workshop. They allowed me to share my perspective on this, so here we are. Now about this workshop, my main goal is to get you excited to explore the data around you, to share some ways of achieving this using Vue and D3. We're going to be using these libraries to provide data manipulation in a reactive environment, and to show how powerful these two concepts are when they're used together. So we'll start small by going over some features in both libraries, and we'll work our way up to creating some nice visuals. Now, hierarchical data will be our main focus for visualizing. However, you can learn patterns, you will learn patterns that can be used in other aspects of data visualization. So without further ado, let's have some fun with Vue and D3. We'll just we'll continue. We'll go to some basic examples while you guys are setting up here. So some examples. Let's take a look at some of these layouts that D3 provides. So we have clusters, which is also dendrograms. They're kind of one and the same. What they are is they are node link diagrams that place the leaf nodes of the tree at the same depth. So as you can see here, every single one of these leaves, which is basically a node that does not have any children, they are all placed at the same level. It's useful when all the leaves should be at the same level for hierarchical clustering or phylogenetic tree diagrams. There's also tidy trees. Now, tidy trees are basically the same kind of approach, except they don't make all of the leaves at the same level. If there is a leaf that is nested three nests down, it will not be displayed at the very bottom if there was another leaf that was, let's say, a depth of 5, let's say. So it's similar in the fact that it does show the parent-child relations based off of links, but it's different in the fact that it displays it that way. Now, there are radial variants of displaying these hierarchical layouts. This is a good example of a tidy tree that we had just mentioned, and you can see here that some of these leaves, they protrude out much more than some of them. You can do the same approach with a dendrogram, and we actually will be doing that in a little bit. There's also tree maps. So tree maps, and also this is you can consider this another radial variant. This is a radial variant of a partition layout. Now tree maps are both tree maps and Circlepacking. They provide a way to display hierarchical data. However, they don't connect nodes to display like parent-child relations. What they do is they nest the children and other descendants inside of the area that we have available. So as you can see here, we have this is a build. This is the module build of this application. And when this is built out, we have several modules, and inside each module, we have different dependencies. So a tree map is a way for you to kind of be able to see the summary of everything all at once, but then at the same time being able to go and dive in and seeing what parts are making up the largest areas. And we can see here that clearly Lodash is taking up a lot of space out of the whole thing, and we can go and inspect this thing to determine where this is to clean it up. And most likely this is probably because we're just importing all of Lodash when we should be just importing some of the functionality of it. So this is a tree map, and this is interactive as well, so you can play around with this and navigate. And then next we have partition. So partition, you actually see these things a lot. This is the Chrome DevTools Flame Graph, and this is using a partition layout. And what a partition layout technically is it produces adjacency diagrams. Think of it as like a tree map. I'm sorry, not a tree map, but a regular tree, a tidy tree, except in the areas where we have nodes that represent an X and a Y point, these things, they fill the space that's available. So think of the space between two nodes. This kind of creates a visual of these filled areas in between each node. So it's similar to a tidy tree. And then we have Circlepacking. So Circlepacking is the same approach as a tree map, in which it doesn't show links to different nodes. It nests them in their area. And this is technically the same as a tree map. You can see here, this is the population of the world. And for each section, we have our regions and our subregions. So it's the same approach as doing a tree map. So all of these different layouts, they're all available inside of D3. And we will be going over a couple of them. But being able to apply a sort of pattern when writing this code to be able to make any layout that we want. All right, so that's our examples here. Now, I'm going to go over some visual theory because I feel that this is important when we want to display hierarchical information that has some sort of meaning. And the way that our minds can process things visually, we can take advantage of some of these techniques. So we as human beings, we don't like chaos. The moment our minds are presented with uncertainty or disconnect, we immediately try to make sense of it. Our human behavior surrounds this notion that everything must have order. So as you can see here, that's kind of our typical human reaction to trying to understand chaos. We try and make sense of it. We are pattern seekers, and it's simply our way of understanding our environment to the best of our ability. This is also an acceptable answer to that. But now, we look at things like this, and it seems like it has order. There's some sort of order. There's motion. There's ways for us to look at this and determine the bits and pieces to be able to break it down into more meaningful information. So we try to figure out the world by using our senses. This is our interface. The human interface, we take in tons of information. Our mind tries to process it at lightning speed. And we process this data by identifying and organizing it into smaller parts, and then reorganizing it over and over in our mind into something that would have meaning, right? This is another example of being able to look at this distribution of movement, being able to group these things into two different categories. For example, here we can look at what's white, what's blue, the direction of them, be able to make sense of things more. Okay, so for our memory, we have our short-term memory. This is where we make sense of things, is our short-term memory. When we see something, new information gets passed into our short-term memory, while old info gets passed into long-term. And this happens faster than our conscious speed of thought to help us make sense as fast as possible before we are consciously aware of it. So this is also known as Miller's Law. This is one UX law, and this states that the average mind can only keep between 5 to 9 items in its working short-term memory. A great example of this is displaying a list of different people and their rank, let's say, and visualizing them, categorizing them by color. If we have more than 15 people, we're going to start not being able to see all of those all at the same time. So breaking them down helps a lot. All right. Okay, so now we have our speed. So what's our speed of how we kind of take things into the world? This is the bandwidth of our senses, and this basically states that we have different speeds depending on the senses that we use. And the amount of information that our senses can allow our minds to process in a given amount of time, this kind of gives us an equivalent to something that if we were to compare it to, let's say, the internet speed, right? So we can see here that our sight, our sense of sight, it gives us the most amount of data to perceive within the shortest amount of time. And this is also important, is that these are speeds based on our perception, right? So it's what our senses can take in before it even gets to our mind, where we consciously know that this is what we're dealing with, right? And actually, you can see here at this little tiny area, that is the moment in which this information becomes consciously available to us. So this is when we are actually aware of what we just saw. And if you can imagine, that amount of information within that amount of time is very helpful when it finally gets to this point. All right, so moving on. Gestalt Theory. Gestalt Theory is a principle that maintains that when the human mind forms a perception or a percept or gestalt, the whole has a reality of its own, independent of the parts. So this means that our brain is capable of generating whole forms of things, particularly with respect to visual recognition, of global figures instead of just collections of simpler and unrelated elements. A good example of this is looking at this Dalmatian. Now, I say Dalmatian, but there really isn't a dog there. It's a bunch of black spots that are moving in a certain way that gives our mind an idea of what it might be, right? Our mind is using our long term to know that this is a dog because we've seen a dog in the past, and we're using this to try and get closure, right? Our minds are filling in the gaps for us. So this is particularly interesting in respect to design and UX, as most of these principles have become well-known laws of UX. Another thing to note is that it seems apparent that this approach of grouping and categorizing, it's in a lot of what we do, even outside of our visual perception. We order groups of information based on a rating of importance. We use this format logically as well as visually perceiving the world around us. This goes into even simple website design or UX architecture when we're trying to provide the user with the most simplest way of displaying all of our information and allowing them to dive in into the different areas, but being able to easily see these sections from a glance. A popular one here is the Gutenberg diagram, which it represents reading gravity, and this is the way that users typically interpret a page design. So this here is showing a Z pattern. Most users will look from the top left to the top right, and then the bottom left to the bottom right of a website. Now this creates a Z pattern of importance. So used for a lot of landing pages, simplistic designs, things like that. This can be used to leverage where you can place important information depending on what you're trying to portray, the website that you're trying to design, things like that. And then once again, this is consistent behavior. More patterns emerge as time goes on. It gives us more insight to what makes a pleasant experience based on our behavior and visualizing content. And it's still the common theme that we perceive everything first before diving into the details, regardless of the layout. So, we look at a website, we look at the landing page, we inspect everything without technically knowing all about it to try and see where we would want to go to be able to find the information that we currently want to find. We analyze the design as a whole to determine which parts we should focus on before actually shifting focus. Okay, so now we have the law of pregnance. Now, this is a fundamental principle of Gestalt perception, and it's the law of pregnance. This is actually a UX law, and it states that we tend to order our experience in a manner that is regular, orderly, symmetrical, and simple. So these are principles that hypothetically allow us to predict the interpretation of sensation, which is often called Gestalt laws. So this is our the concept is that by displaying these things and using these kind of tricks that our visual sense gives us, we can interpret what the user might sense, I guess you could say. And again, this implies that the mind understands external stimuli as a whole, rather than the sum of its parts. So these wholes are structured and organized using grouping laws. So we use these to kind of interpret these sort of groupings. We have law of proximity. Law of proximity states that when an individual perceives an assortment of objects, they perceive objects that are close to each other as forming a group, right? So in this example, we see a bunch of blue circles, and we see a cluster of circles that seem to be together. We can even see that there's a shape that it forms, which is a triangle, but we can see that it's grouped separate. Now we have the law of similarity. So that also states elements that are within an assortment of objects are perceptually grouped together if they are similar to each other. So now we have all of these stars. These stars are grouped by proximity, but then they also have certain characteristics like their color, right? And we can see that they stand out. And by doing this, we can see everything as a whole and get a better sense of these groups that they're in. In this case, we can see two groups, and inside each group, we see two more groups of the opacity of the stars, right? Giving us these different sections to be able to focus on. And then we have the law of closure. So this states that individuals perceive objects as shapes, letters, pictures, etc., as being whole when they're not complete. Specifically, when parts of a whole picture are missing, our perception fills in the visual gap. And so you can see here that we sort of make out a circle. In this case, we can make out a square. In this one here, we see triangles that aren't technically there. This is also the same concept as if you were to read a paragraph of words in which each word has the same first and last letter, but the contents inside each word are mixed up, right? We can still easily be able to read this paragraph without a problem, and it's because of this. Now we have law of symmetry. So this states that the mind perceives objects as being symmetrical and forming around a center point. It is perceptually pleasing to divide objects into an even number of symmetrical parts. So having this in there, it gives a sense of a pleasant experience to the user. And then we have law of common fate, which states that objects that are perceived as lines that move along the smoothest path. These experiments using the visual sensory modality found that movement of elements of an object produce paths that individuals perceive that the objects are on. Now that's a lot of wording, But a great example of this is if you were to watch a flock of birds. Because they're going in the same direction, you will tend to group them together, right? And then you have law of continuity. So this states that elements of objects tend to be grouped together and therefore integrated into perceptual wholes if they are aligned within an object. So in cases where there's an intersection between objects, like here we can see there's intersections by color, and we will tend to perceive the two objects as two single uninterrupted entities, right? So when you see an object and it's made out of parts that seem to be continuing in a specific direction, we will tend to kind of group those. Okay, so now from all those laws, we need to kind of determine by using these laws what can we show that has certain value, right? And this brings up these visual variables. So when we process data visually, we use a collection of different stimuli to inspect and analyze this information, right? These are the kind of the basic core concepts of us just kind of seeing things, right? Being able to see things in groups and such. Now, depending on the type of information, these variables, they play a major role in how we retain the data in certain formats. Now, if you could imagine, we've got think of these as dimensions. We have size, value, texture, color, orientation, and shape, okay? Now, for each one of these things, they can portray certain parts of information better than others. And this is all depending on how we want to perceive this, right? So if we're looking at a bunch of circles, let's say, and we want to associate them or try and group them by which ones are similar to each other, size is not a good fit. Using size as the dimension would not help you that much into seeing, right away these groups. And so this chart helps you determine what you could use. If we did want to see something, see a collection of objects that were similar, that means that we can scroll down over here and we can see that, well, texture is a good fit. Texture is a good fit if we want to see similarity. Same thing with color, orientation, and shape, right? Now, if we wanted to see things that were different from each other, then in that case, size would actually be a good choice to see, right? And you can see by these examples here that it shows the different areas in which size would work for selection, order, or quantity, or association. Same thing with value, texture, color, and orientation and shape. Now, as you kind of go down to the bottom right here, this is where, these are conventions leading to elementary reading level. These are symbols, characters, things like that. They get a little bit more complex the farther down you go. So this is a great way to kind of reference what you should use in certain areas. Now that's visual theory here is, the whole point is trying to make whatever you're going to create something that has something where people can walk away from with some insight, right? To understand what it is they're looking at, and depending on the use case, it's a great way to go by it. All right, so moving on. All right, this is where we're going to get into some coding. We're going to start real simple with Vue. Now, if any of you already know Vue, that's okay. We're going to we'll do some simple exercises. Now, Vue, and if you look at, you can go to Vue.js website and check out their explanation of it. They have a great video of it. I'm not going to go here and read all of this, but it's a way for us to modularize and create these components that are reactive based on the data that we give it. It's state management. We only worry about modifying data, right? Actual data content. Vue allows it so that if we want to render or display that data, it puts it in a more reactive state where we don't have to manage how it's going to render. It will just render. All right. So there's nothing wrong with using other frameworks that do the same thing. If it can do the same job, then cool. I did choose Vue though, however, because there are parts of it that complement D3 and its usage pretty well. And we'll go over that when we make some layouts up, below here. Now, there's two parts. There's the template syntax for Vue, which it works well with, and that is that Vue components they have a template that serves as the markup of the component instance, right? So it's basic DOM structure, and when we're making these visuals, a lot of times we use SVGs, and SVGs are the same approach. They are a way for you to put DOM elements or SVG elements inside and be able to nest and do all that stuff. So technically we can make components in Vue that are SVG elements that we can fit and nest inside of its any SVG that we want. So this is very useful, especially in the realms of trying to visualize something in some SVG chart. Then we have reactivity. So Vue will observe and render information provided within data objects. If at any time the values change, Vue will handle it for you, right? So the first step we're going to do is we're going to make a component. Now, components can be imported and used inside of other components, and this is just a simple walkthrough of what a single file component pretty much contains, and then how we can use it. So we're going to be writing a very, very simple single file component. It's not going to have anything in it. We're just going to have it say hello. And we're going to wire it up to use these core features here. So first, what we'll do is we're going to create the file. So we can click and open this button here, and we'll be able to see this my component over here. Let me actually make this a little bit bigger. All right. Okay. So what we need to do is we need to create a component that we would then replace all of this information here, right? So what we'll do is first we'll make a new component. Okay. Let's make it, we'll call it my component. So we'll say my component.vue. All right, and then we will add our default setup here. So for the template, we're just going to put in we'll just put in a div, let's say here, okay, and then we're going to say hello, like so. All right, nothing too much to it, and we can actually even remove style like that. Okay, so we've created a component. Now we just have to import it and use it. So if we go back over here, we can replace all of this information, right? And first what we'll do is we'll import our component. So we'll import my component from, and then it'll be my component.vue. Right. Now you can put the extension there, .vue. I tend to do that all the time, but I don't think it's necessary in some cases. So once we've imported it, we have to specify that it is a component. So we'll add a components object to the Vue, this Vue component here, and we'll assign my component to be at a component. Now, writing it this way, this is kind of a ES6 shortcut of writing my component equals my component. I can say some component like that and make it equal this, right? And in that case, our component would be named this. So for the meantime, we're just going to make it my component, and all we have to do is add it in here. All right. Now, if we do this, what we should be able to see is a simple, some simple text that just says hello. So as you can see here, we've imported this new component, and now whenever we want to make changes, we can go inside of the component we made. It's already rendered, and everything will work out, right? Now this goes along with being able to nest inside of different components. You can have slots, which allow you to kind of inject any component that you want from the top level. There's tons of different use cases for this, but just to show how to typically kind of use a single file component, you would go like that. All right. So moving forward, we'll jump into reactivity. Now everything in Vue is pretty much reactive, but there are some use cases in different areas. There's a reason that you use computer properties compared to watchers, things of that nature. And we're going to go over kind of the simple, the three different aspects of it. We have our data properties, we have computed properties, and then we have watchers, right? So what we'll do is we're going to create a component. I'm sorry, we're going to open up a component that's already there for us. And we're going to make a simple calculator that'll add two numbers, right? So if we open up this component here. All right, now it wants us to, we're going to replace this. We're going to replace it with some content here. So instead of adding this button, let's remove that. We're going to add a div. And inside this div, we're going to have an input. It's going to give a V model, right? And it'll be a number. And we'll make it equal A, right? Now we do have to assign these A values here. And we'll do that in a second. So we'll make two inputs. We'll have one is A and one is B, right? And then we'll add a little header here. So we'll say H2. The sum is, and then we'll say A plus B, right? Now we don't have A and B yet, so we need to make those. We'll say inside of our data object, we'll say data, and then we are going to return A, and we'll set it by default to be 0. Same thing with B, we'll set it by default to be 0. Now when we do this, we should be able to see two inputs, allowing us to change this to whatever number. That number will then update these, and because this is showing the addition of these, this should update automatically as well. So let's save this out, and we'll go over to our main setup here. As you can see, we have 0 and 0. This is A, this is B, and this is A plus B, right? Now if we did 3, sum is 3. If we did 2, sum would be 5, right? Because A is 3 and B is 2. All right, so very simple use case of doing this. Okay. All right, so now let's move to computed props. Now, there's many use cases for computed props. The idea is pretty cool, though. You can create an object based on multiple values that are being observed, right? So for an example, we'll do this with A and B. Now, we're showing A and B together, right? We're adding these two here. But let's create a computed property that would basically change and become this value whenever things update, right? So we're going to create a computed object, and we're going to say, we're going to create an object called C, and what we'll do is we'll return this.A plus this.B, right? Now if we do this, this is the same thing. It'll update automatically up here. So instead of doing A plus B, let's render out our C property, right? And if we do this, we shouldn't technically see a huge change here, but you can see that it is using the computed property C and displaying it here, right? Okay, pretty simple. All right, so now let's get into watchers. In our computed property here, we're just returning an object, right? Now this technically is a pure function, which means that there's no side effects. It's not going to call another function inside of this function, right? It's just returning these two values together as a new value, right? Computed properties need to be like this. However, there are use cases where we do want to have side effects, and that's where watchers come in, all right? So what we'll do is we'll add a reduced property for our data object, and we're gonna make this so that whenever the C value changes, we will set the reduced value to be the exact same value, and then we will start a loop, pretty much a request animation frame loop, right? And every loop we're going to subtract from, reduced by a little amount until it hits 0, right? Now this is kind of a side effect example. You know, when C changes, we don't want to start any animation frames. We don't want to do any of that. We just want to watch to see when C changes, and in that case, we can trigger an event, aka like a side effect, right? So, you know, in this example here, it's got the same stuff that we have set up, right? But what we'll do is we're going to add our watch property, right? So let's add watch. And if we go inside here, we're going to add a value called C because we're going to watch for C. And val is going to give us the new value. So when this val changes, we're going to set our, and before I do that, let me add reduced up here. Reduced, I'll make that 0, okay. All right, so as soon as C changes, we're going to change reduced to equal val, right? So we're going to say this dot reduced equals val, right? So it's going to equal the same, it's going to equal what A and plus B is, or what C is, right? So this dot reduced equals val, and then we'll trigger off an event to start subtracting things. Now, we'll add a method that does this, and we'll call it subtract. So in here, we'll just type in this dot subtract, like that, all right? And then we have to make this method here. So we'll call a method called subtract, okay? And so inside of track, we're going to subtract our reduced number by, let's say, 0.1, right? So we'll say this dot reduced minus equals 0.1. And then what we'll do is we'll say if, and this is where we're going to kind of do our looping of this same function. We're going to say, well, if the reduced value is less than, I'm sorry, if it's greater than 0.001, right? Then we'll continue subtracting, right? To do this, we'll just request an animation frame, and the callback is going to be the same function, subtract, right? Otherwise, if it's not greater than 0.001, what we'll do is we'll set it to equal 0, right? So we'll say this dot reduced equals 0. And in this case, it's not going to request another animation frame. So as soon as it gets below 0.001, it will automatically be 0 and the looping will stop, right? So we'll clean this up a little bit, right? So we'll set reduced minus equals 0.1. If this dot reduced is greater than 0.001, we'll request an animation frame to then continue subtracting. Otherwise, set it to 0, okay? Now, all we have to do is display our reduced value. Right, so let's do that. We'll say h4, we'll say reduced, and then we're gonna put in our reduced, there we go, okay. All right, so here's our reduced value, it's 0. Let's go ahead and do this. Now we should be able to see we have 0 and 0. Now if I put in 7, all right, we'll have reduced as 7. Let me make sure I'm not here. Give me 1 second here. I gotta fix this. Oh, I must have. Okay. Sorry about that. I misspelled. All right, so this should work now. All right, let's try this again. So if we did 9, you can see that every time C changes, right, it's going to start this animation frame request. And it's going to subtract by the number, right? So this is our reduced number, and it'll keep going until it's less than 0.01. In that case, it'll be 0. So this is a good example of watching for when something changes, not necessarily returning a new value based off of those, but then applying some sort of action or something based on the new values of whatever has changed, right? So this kind of goes over the basic things. We've got our data, we have our computed, and then we have our watchers, right? All right. Okay, so let's go into D3. Now, before we get into D3, I'm going to take a quick 10-minute break. We'll be right back after this, but give me about 10 minutes or so. I think in the final video, we'll cut out these little breaks, but I'll be back. I just have to take care of something here. All right, we'll see you guys shortly. All right, and we're back. All right, so a quick recap. We went over some of the visual theory, and we went over the section of getting started with Vue. So now we're on the section of D3. In these lessons, we're just going to use our console, and we'll be working with data and how to transform the data, do different things with it. So let's go ahead and we'll go into that section. But first, let's try and see, what is D3. There's a guy, he's a pretty cool guy, his name's Elijah Meeks. He wrote a pretty good article titled D3 is not a data visualization library. And the way he described it is exactly right. D3 is like a utility library. It's filled with useful tools that, when used together, allow you to create some pretty cool things. So, think of D3 as 5 different things that you can do with visualizing data. There's, the visualization part, obviously. And then there's, animation parts, there's analysis, there's data utilities, and then there's DOM utilities, right? Now, when using D3 by itself, things like animation, DOM transformation, those are handled by D3. But when you have something like Vue, you can leverage its reactive nature to exclude this part of D3 altogether, meaning that you can have Vue kind of manage the DOM and how everything looks. The same thing with interactivity and whatnot. And use D3's sort of data transformations to be able to apply to our our reactive data, right? So the parts we do care about, we have the data utilities, right? And this is deals with different things. There's time, interpolation, collection, array, format, random, time format. All these different parts of D3, are used to be able to modify data or transform the data. And then we have the visualization part. Right, so this is the bread and butter. Think of these as ways to transform your data into meaningful visual information, right? Like X and Y positions, sizes, things like that. In this one you've got shapes, which is we're going to go through some of those. There's Voronoi, hierarchy, contour, path, chords, axes, brush, color schemes. All these different things work in conjunction with visualizing this sort of information. Okay. All right, so let's transform some data. Now we're going to open up DevTools. You can hit F12, and we'll get to our DevTools, and we just need the console, right? So we'll make the console kind of big here. And what I've included in here is we have 2 global references to some stuff that we need. First, we have D3. Now we have D3 as in its entirety, so we have everything we can use by just calling D3, right? And then we have our data set, okay? So this is our data set here. Now, our data set, real quick, let me go back to walking through D3 and how we could use some of D3's functionality versus, ES6 native functionality. So a lot of these methods are built into JavaScript by default. We don't need to use D3 for all of the functionality. We could even use things like Lodash in order to create the data structures we need. But just like Lodash, D3 does offer additional utilities to transform the data. Some of these include bisect, which is like binary search. We've got handling of null or undefined values when doing summarizing information or sorting information. We have out of the box ways to be able to load and format CSV files, different JSON files, things of that nature. Visual data for layouts. And this is kind of going back to providing, X and Y positioning, things like that, depending on the data that you provide. And then, nesting. I mean, these are just some examples. There's a lot more. The main point is that you use D3 to transform your data while you use Vue to display it, right? So Vue displays this information, D3 transforms it. Okay, so let's start playing with some data, and this is where we went over here. Now, this data set has 9,365 items, and these are items that are in the Google Play Store, right? If you look over at the interface for a Play Store item, you can see here you got its Android version, content rating, its current version, last updated, got app category, genres. It's got a ton of info for each item, each individual item, and that's out of 9,365 apps, okay? So since we have a habit of grouping and ordering things based on a level of importance, we can split this huge list up into groups to find out some information, right? And we can do this using D3's nest method. Okay, now the nest method returns an object that contains various grouping methods that can organize and rearrange your data set, right? So when you make one of these things, you're making a method. You're not passing the data set to it yet. You're setting it up so that when a data set is passed to it, it knows what to do, all right? So here's our data set, right? And what we'll do is we'll make a new nest object, okay? So we'll say my nest equals d3.nest, okay? So you can see here that when you create this my nest object, it is an object that contains other objects. It contains an entries method, a key method, map method, object, rollup, sort keys, and sort values. So all of these methods are available. Now, let's think on how we would want to, order and group these apps, right? So out of these 9,000 or so applications, how can we kind of group them into different categories, right? One of the dimensions that we have category, right? So category is a string. If we looked at our data set, let's just look at the first few, right? So we've got the first one, we have the categories in dating, right? Second one down, we've got category is family, right? So we could split this entire list up into groups based on the category of the item, right? So let's do that. Then we have our my nest object, right? And to do this, we use the key method that it provides, okay? So what we'll do is we'll say mynest.key, right? And what we pass key is we pass it a method that is looking for a single item, right? And we are returning back a value based off of this single item. So in this case, our item is going to be each app that's being iterated through this entire loop. And we're going to return the item's category, right? So we're going to say item.category. Oops, category. Right? So mynest.key item, we're passing in, we're going to return the item's category, right, for each one. Okay? We'll do that. All right, now, looking at this, we still have the same methods and stuff. It doesn't really look any different, right? But let's try and pass our data set into one of these methods, and we'll use the object method here, okay? So we're going to say mynest.object, and we'll pass in our entire data set, which is the 9,000 or so items. And if we do that, we can see that now we have a new object, right, that has split up all of these applications into those, into what we had specified, into the same category. So art and design, these are all of the applications that have category of art and design. Auto and vehicles, you can look at all these things, categories, auto and vehicles, so on and so forth. So you can see that it's created a group of all of our applications based on the category they have, right? Which is great. This is awesome. We can easily kind of sort things in this sort of fashion, okay? So what if we want to nest even further, right? What if we looked at all of these and we say, okay, well, here we're grouping it by the category, but then I also want to split them up into other subcategories, right? Let's say by the amount of installs. Okay, so let's do this again, right? Now we have my nest. We've already applied this key method, so now my nest has changed to when we pass in data to it, it's going to group things by category. But let's add another subgrouping mechanism, right? So we're going to add another key, right? And this time it's going to be the amount of installs, right? So we'll say item, and then we'll say item.installs, right? Oops. Installs, right? Okay, so this key has, we've now attached another method that this thing will go and run through when we pass in our data set. So let's see what that looks like to our data set, right? We'll do mynest.object of our data set, and let's see what it gives back. So it gives back the first level, right, which is our categories. Okay. Now if we go into each one, now we can see that it's grouped it even further. In this case, art and design has 1,000 and plus let's see, which one was it that we passed in? The amount of installs, right? So we've got 1,000 plus installs. We have 3 of them. We have over 1 million installs. We have 4. So we can see here that the majority right away we can see is 10,000 plus has the most, seems. No, I'm sorry, 100,000. That seems to be the most general one, right, for art and design. And we can go through each one of these things and see that they're nested like this, right? So this is kind of a cool concept that we can just keep nesting. We can do this forever and ever, as a matter of fact. So let's do another one. Let's say let's see how many, based on these categories, right? We've grouped it by the category, and then we've grouped them by the amount of installs. Let's group it even further and find out of all these installs which ones are free and which ones aren't, right? So let's do that. We'll say we're going to add another key. So mynest.key item, and then we're going to do item.type, right? Item.type, and I think it's capitalized type, like so. Okay. So now we've grouped by the category, then we've grouped by the installs, and then we've grouped by the type, right? So now if we pass this in again, we can see that it's grouped by the category. Let's pick some random one here. Maps and navigation. We'll look at the amount of installs, right? So we'll pick one of these. And then if we look inside of all the installs, now we have 2 more groups. We've got free and we have paid, right? So these are the different values. So you can see that we could easily group and order these things based on what we currently find important based on the data set. Okay. So yeah, we can keep applying more key methods. And this gives us our hierarchy, right? It gives us a hierarchy of importance. All right, now there's 2 rules of thumb when doing this thing, all right? Every time we apply a key to this nest object, you cannot go back. You can't remove a key that you just added. You can't reorder the keys. You can only just create a new nesting object that would give you these methods to then apply to a data set. But you can't revert. You can't go backwards. Another rule is that the order matters, right? We have ordered it by the category and then the amount of the installs, and then if it's free or not, right? It's because it's in that order that we're able to group these things. Now, if we ordered it by the amount, if it's free or not free, and then by the amount of installs, obviously we would have a different structure, right? So there's always going to be an order, and you cannot revert. Now, if you have nested keys and want to reorganize, yes, you will have to start over. But what is nice is that D3 it returns these values as it returns objects and methods, right? I mean, in this case, nest is returning an object that contains methods inside of it, right? Each property inside of that object is a method, right? But either way, you gotta kind of think like, well, we could set up something where we have a key or a nesting object, right? But we would make it a computed function, right? So if we pass in, let's say, an array of strings, we can say, well, for each one of those strings, we'll make a key, and it will return that item's that category or that dimension, right? So if we pass in type and then category and then installs, then we can essentially create a new constructed hierarchical data set out of just rearranging the order of the array of strings, I guess, if that makes sense. We'll do that later. So this means that when we do this, even if we put in a computed property, we're not passing in a ton of data for it to operate on every single time we change something, right? We're only changing the method, in which when we do call it, it would then change. So it's like we're computing new methods instead of the actual value itself. All right. Now customizing keys. So in this example here, we pass a function that returns the value of an item property, right? So what we've done is we've made a key, and all this function does is it returns the property of what item is being iterated, just the property, right? So let's start over. We're going to make a new nest object. We're going to say my nest equals d3.nest, right? And now another thing to note is that we can chain onto these things. And this is kind of a typical behavior from D3. So for example, I've made this d3.nest, right? Now I can say my nest.key, right? And I'll say item, we'll do item rating. We'll find the rating of it, right? This in itself is returning itself, right? So I can chain. I can say a key item rating dot key item dot installs. Oops, installs, something like that, right? So you can chain onto this thing and it always returns itself, right? We don't have to do that in this case, but just to let you know. All right, so we're going to group all of our items based on the rating of things, right? So we'll make our nest do a key of item. We're going to pull the rating of the item. So now if we did my nest.object, right? Let's get our object again of our data set. If we look at this, this is nice, I guess, but each one of these values they're in decimal. They have different decimal points, right? So what if we wanted, instead of passing this in, I mean we're just passing the rating of the item. What if we wanted to make it so that these are kind of more generally grouped, right? Group the ones that are ones, group the ones that are twos, and so on and so forth, instead of this. Okay, so we can do that by modifying how we're going to return the value of each item that's iterated. So let's do it again. We're going to say my nest equals d3.nest, right? And now instead of passing in just the rating, right, we are going to say my nest.key, the item, and we are going to return the floored value of the item rating, of the item's rating, right? Item.rating, like so, right? So math.floor item rating. So what that will do is it will then, my nest, oh, whoops. Okay, so if we did my nest.key item math.floor of the rating, that will give us a key method that once we pass the data set to, it will then organize it up much better. So let's try that now. So we'll say my nest.object, we'll pass in our data set. And now if we look, instead of having it with all those decimal places, we've arranged it in a way where it's based off of the floored value, right? So we've got 56 of them that have a rating of 1, 231 that have a rating of 2, 1,710 that have a rating of 3, and so on and so forth, right? So this is important to note too. You can construct the keys to not be exactly what the item's value is, but rather whatever method you decide to use. Okay, so moving on, we'll go to hierarchies. Right now, this is technically a hierarchy, right? But there's no sense of recursive pattern, right? Each object has, this thing is nested, but what we have to do is we have to say for each object, a hierarchy is considered, it's a unidirected, I guess, hierarchy. But each node would have a possible parent and a possible value of children, right? Or something that would specify that these are the children of each one of these things. Right now, we just have this large object that's just grouped by other objects. Okay, so a hierarchy, we're going to be using D3's hierarchy, right? And what hierarchy will do is it will wrap another object around each one of these different sets, okay? And essentially create this hierarchy with extra information to it, but then keep this data. It won't modify this data. It'll simply just return back to you a new object that for each one of these items has an object wrapped around it that gives you other things that you can do with hierarchies. Right? So let's try this out. We're going to create a new nest, and actually let's call it Nestor this time. We're going to call it Nestor. We're going to say Nestor equals d3.nest. All right, and we're going to add some keys. We're going to do the same thing. We'll say nestor.key, and we'll say item, and we'll return the items category this time, just like we did before. Right. Let's add another key. We'll say key item, and we're going to return the item's content rating. Right. Now I have to do this because there's a space in there. All right, so we have one key to return the category, the other key to return the content rating, and then we're going to do another key, and we're going to return the price, right? So we'll do that key again, say item, and we're going to return the item's price, right? Okay, so now we have this nestor. It's going to return back to us these objects and whatnot. Now, normally, like what we've been doing is we've been just doing object of data set, right? Which would give us that sort of that scope of things, right? Everyone, and then here's the different prices, okay? So instead of object, if we did entries, right? Nestor.entries, and we pass in our data set, we technically get the same information, but the format of it is a bit different. For one, it's an array, right? It's an array of objects. Inside each object, we have the key of that object, so in this case, dating. And then we have values, which is then another array. And if we dive into that, we can go inside of each object within those and notice that it also has a key. And it also has values, which is an array as well. So if you look at this format, you can see that it's set up in a recursive structure of being able to find out information. And this is what we pass over to our hierarchy, right? Now, in order to do this, there's a couple rules. Well, there's basically one main rule. This rule is that a hierarchy must have a root node, right? Now, this is just giving us entries, right? Entries is it's an array. It's like it's the root's children, I guess you could say, right? So out of everything that you're doing, you have your entries, your main entries, and these are your immediate children, which means that each one of these things should have a parent, right? So now what we'll do is, in order to make this work, I mean, we have to have one single object that has a key and it has values, right? In this case, these are all, this is an array, right? So this is technically the children of root. So we'll make a new object. We're going to say tree equals, make a new object of it, and we're going to keep it in the same kind of format that all these other entries are. We have a key. In this case, we'll call it root. And then for values, right, values represents its children, right, because each one of these different entries here has a values object as well. I'm sorry, a values property. So, so for values, we're going to say, well, the values is going to be our entries, right, nestor.entries of our data set, right? So now if we do this, we will notice that we have a key and values, right, of one single node. The values now are this array of entries, and if we look at each entry here, we have another key, and we have more values, right? And inside each one of these, we have another key, more values, key, values, right? So we can see that we have this, we're matching this same pattern, okay? All right, so now that we have our tree, right? We have our tree object right here. Now that we have these, we create a hierarchy object, and we pass this into the hierarchy constructor method, I guess you could say, right? And what will happen is you will get back a new object. So let's do this real quick. We're gonna make a new hierarchy. We're gonna say h equals d3 that hierarchy, okay? And we are gonna want to pass in and let's look here. If you see here, we have data and children, right? Oops, let me go back to that. All right, we have data and children. Children is going to be a method that we can optionally pass that will tell this thing for each node what property represents its children, okay? And we have to do that for our setup because by default our the property name it's not the one that hierarchy normally takes. So we'll do that. Okay, so we're gonna say Here, let me get rid of that. All right, so we're going to say h equals D3.hierarchy. Now we're going to pass in our tree that we just made, our tree object, right? That is the root element of nested objects. And then for children, we're going to pass in a method that will return back the children property of each node. In this case, it's called values, right? So in each one of our, each one of our sections, we have our key, and then we have values. Values is the children. So we'll say item, and then we're going to return that item's values object, or values property, right? So now if we do this, we can look at H, and we can see that H has a couple properties. It's got children, it's got data, it's got depth, height, parent. Now this is the root node, so it doesn't have a parent. But for each child will have a parent of itself, so on and so forth, okay? All right, so, and if you compare this, and also just to mention that data, this is the original data, right? It's not, it will be included inside of this object, but it more is like a wrapper, right? These are the original values, okay? So if in the data set, in your original data set, you change something in here, this will ultimately change as well because it's just a reference to it, okay? Okay, so let's look at some of these. We've got depth, height, children, parent, right? There's also a couple other things in here that you don't see right away with these objects here, right? I mean, these are just basic properties. But now for each node, we also have some functions that help us out with things, right? Now if we do H, and we go to, let's say, children, let's go to the second child, right? This is a hierarchical node. Now for each node, we have things such as links, right? So if we look at links, we'll get back all of the links for this child and this child's descendants. And this meaning that a link is basically something that connects its parent to its child, right? So for each child, here's our child. The target would most likely be the parent, right? This is typical way of being able to grab this stuff, right? And it goes on any level, any single node that you have, you can get the links of that. You can also do things like getting the descendants, right? So being able to get the descendants of all of our nodes. You can see here we have 9,886. That's because it's including all of our leaves. Our leaves meaning nodes that don't have children. So we can say h.leaves and see how many there are. And you can see there's fewer leaves than there are here. So you can see that there's 9,365 of them that are actual items themselves. These are the ones that have no children, which in our case is the actual item itself. It's not where it's been grouped. Okay. So now, yes. So each descendant is considered a node. There's two different types of nodes. There's a leaf node, right? Doesn't have any children. Data within these nodes is an item of the data set. And then branches, which is the opposite of a leaf node, right? We also have links, which we went over. Okay, so since we can do all this stuff, that's great, right? It's wrapped this in some information that we have that's helpful, okay? But now we need to kind of visit through this this hierarchical structure, and we need to do a couple of things. All right, so the first one is summarizing. Now, by default, any sort of hierarchical structure can be summarized by its count, right? So if each node represents something, even if it doesn't have a certain value associated to it, its value is still, I guess you can consider it 1, right? Because it exists. So if there's 3 children in a node, well, that node's value could be 3, right? So let's do that. Now, the easiest way to do that is we call this count method on a hierarchy. We can also do this on any node. We can say children to dot count, right? So it doesn't matter what node you can count. What that will do is it will recursively from its leaves all the way to top. It will summarize just how many children, right? So if we did count, let's try this out. We'll do count. Okay. Now if we did count, and we look at H again, let's just look at H. If we look at each node, we now have a new value, right? And this value represents the summary of what we have just called. In this case, it's just going to tell us how many items are in each, or how many children are in each node, right? So if we went down to, let's say, you know, so here's the immediate children, right? These are the categories. So if we go into, let's say, communication, right? We can see here that in communication, there's a total of 328 apps, right? Inside the children, you have these other ones here. You've got the value for here is 295. Value here is 24, right? So it summarizes everything all the way from the bottom up. Okay, so this is useful, and it's especially useful when you want to visualize, you know, data that has some sort of quantifiable value to it, or quantitative value to it. Okay, so we went through count, right? And we now have a value property on each node. So if each node can represent other values, right, we can summarize it in a different way, right? So let's say instead of knowing the count, let's say perhaps we want to know, we want to summarize this thing by its amount of reviews, right? So each app, we look at, let's look at one of these, let's drill all the way down and find one here. So here's some apps. And if we look at each app, we have some properties on here that could be numerical, right? So let's see, we've got reviews, right? So the amount of total reviews that this application had only had one, right? This one had, let's see how many reviews this one, okay? Maybe there's a couple in here that might have more. This has 59 reviews, right? So we could summarize this whole entire thing, this entire collection, based off of the reviews of each app that's in this Play Store data set, right? So to do that, we just simply call, instead of calling count, right? We did this last time. Let's call sum instead, right? Now, count is kind of the same thing as sum. It's just kind of a shortened way of doing it, which it passes in a method that gives a number based off of if it has children or not, okay? So instead of us doing that, we're going to summarize our data set, right? And we're going to summarize it based off of the amount of reviews, okay? And to do that, so for each item, we have reviews as a property, right? And if we summarize this, even if they're formatted as a string, D3 will take care of this. And once we do this, we'll be able to look at our hierarchy again. But this time, our values are much different now, because this doesn't represent the amount of children each node has. It's the actual amount of reviews in total for all of these different, on all these different levels. And if we look at the children, we can see that all of these are the categories. And we can look and see for each category how many total reviews. We can also dive in even deeper and say, well, inside of art and design, how many reviews were there for everybody? And we can see here, well, there was, let's see, 1,445,792 reviews in total for apps that are part of, what is this category? Let's see, we've got for everybody, for everyone inside of art and design. There we go. All right. Okay, so this is important. It's crucial actually, because when you're going to want to do these layouts, it needs to know this information, and we can display hierarchical layouts based off of these different values. Obviously these values are different. For rating, we could pass in something where it's the amount of downloads, let's say, or things of that nature, right? Each node can technically have different values associated to it. All right, so now, so that's great. We can do all this. We can organize, find all this information. There's also another important aspect, and that's sorting, right? So given that we organize these things by order of importance, it makes sense to be able to sort each group of information by the value that we give it, right? So real quick here, let me just double check. Okay, so if we go to group these things, we'll clear this out. We have H. H is our hierarchy. So if we want to order or sort each one of these nodes, right? We could do so pretty easily. Hierarchy includes a sort method as well. So we have sum, we also have sort, okay? So what sorting does is you pass in a typical sorting method, which we'll write it out. We'll say, so for sorting, we'll say item 1, item 2, right? These are the parameters that are passed. Okay, so when this sorts, it's going to compare these items and it's going to, order them in a specific way, okay? And in our case, what we're going to do is we're going to order it by the value of each one of these items, right? So we're going to return the item 1's value, right? Because it's added that to our hierarchy node, minus item 2's value, right? Now, if we do this, it should be able to reorganize our hierarchy in a way that things are ordered based off of the value of each node. So if we look at here, inside of our children, we can see that the top one has the least, whereas the bottom one would have the absolute most, right? And we can do this, and not to mention too that, this goes to say that each subsection is also ordered, right? So we can see here that this one has the least, whereas this one would have the most, okay? And sorting it could work the other way around. We can subtract the item 2's value from the item 1, and that'll give us our data set in a way where each item represents at the very top the most and at the very bottom the least. Okay. All right, so that's sorting. All right, let's go to another one. This is scales. So we're gonna mess with some scales real quick, and these are pretty straightforward, but they are fundamental to visually representing information. All right, so as stated in the documents for D3 scale, although most often used for position encoding quantitative data, such as mapping a measurement in meters to position in pixels for dots in a scatter plot, for example, scales can represent virtually any visual encoding, such as diverging colors, stroke widths, symbol sizes. Scales can also be used with virtually any type of data, such as named categorical data or discrete data that requires sensible breaks. So a simple date scale can be created just like nests, right? Where we apply an object, and in this case we'll say date scale equals D3.scaleTime, like so, right? Now, what this is it's turning date scale into an actual method, right? Date scale, we can pass in an object, right? We have date scales, it's a function, see? So that's what D3 scale returns. It doesn't return, nest returns an object with different methods inside of it. Scales actually return a method of themselves. All right, so in order to map the data values to visual variables such as position, we use domains and ranges, okay? So the extent of our data is the domain. So since this is dates, let's make our domain of this date scale. We're going to give it a new date of, in this case, I could put in my birthday, so 9/2/1985, right? So that's our low end, right? And then we're going to want another date. So let's do date.now, okay? And we'll pass this in. And we'll set the domain to be this, right? Meaning that, it's going to be up until, I guess, 5 seconds ago when I typed that in, right? So this is a number, this is a number. Okay, so now if we were to say date scale, we'll pass in a new date, and let's put it as a date that's somewhere in the middle, right? So we can do like, let's say February 3rd of 2012, let's say, right? So that's between my birth date and now, right? So if we did this, it's going to give us a number, a numerical value. And what this is doing is it's mapping our input into, based off of the domain that we've applied, right? I'm sorry, based on the range that we have provided. Now, by default, a range is it's an extent of between 0 and 1. It's a minimum and maximum of 0 and 1, right? So we can change this value to represent something that would be like with positioning, okay? If we did date scale dot range, and instead of giving it a 0 and a 1, let's give it some numbers. We can say 0 and window dot, what is it, inner width or something, right? So now if we do that and we change the range, if we pass in this same date, instead of it giving us a value between 0 and 1, it's going to give us a new value between 0 and the inner width of this window, right? Which in this case, it's 1493, okay? So this is, it's great that it's able to map these things for you. Now we can pass in other different visual dimensions, right? Let's say, for example, color. We can say that instead of giving the range of our date scale a number between 0 and, for example, here we give window.innerWidth. Let's try and do this, and actually this might mess up, but let's try and do this. We'll say, instead of applying the range to be 0 and this, let's pass in a couple colors, right? So let's pass in red, and we'll pass in green, let's say, okay? So if we pass this in, what would happen if we send another date, right? If we did that, okay? Now you can see here that it's giving us back a color associated with this, okay? This means that now we've been able to map this visual variable, which is a color association, and it will give us the value between here and here, right? Which is kind of cool. So we can also do things like looking at the ticks of any scale, right? So for this date scale, it has a method called ticks, and we can pass in, let's say, 10 different ticks. And if we look here, our ticks are dates, right? We have Monday, Sunday, Saturday, Sunday. So each of these things are kind of spaced out evenly throughout our entire data set. So it'll give us you know, an amount of different dates in this example here, right? Now we can do the same thing by getting the colors, and all we would have to do is just basically map this to its own scale, right? So we could say date scale dot ticks 10 dot map. We'll just map these things, right? So we'll say date. We'll just do D for date. All right, so we're going to return the date scales function, and we'll pass in D. Okay, so now if we do that, now we have our ticks. We have 10 different ticks of each color. All right, so this is a typical way of working with scales. Okay, now there's only a small section of what is available regarding scales. They each have their own strengths and weaknesses, but they can represent certain values better than others. All right, now this example is a date scale, or a time scale, I should say, which is technically the same thing as a linear scale. But you also have log scales. You have let's see, there's scale pow, there's scale square root. There's different things that you can do. Scale band, scale point. There's many different ones. So I would recommend kind of looking at all of them. Not all of them have domains or ranges. Some of them work specifically. There's one that's let's see here, scale. Let's see here. There's scale. Yeah, you can see there's a ton of them. We've got sequential. Sequential. You technically pass in an iterator for a sequence of things. So let's say you wanted to pass in a function that would return give you a color based on different numbers. Aside from this, you pass in a method. But we can get into that later. So that's technically the scales, okay? All right, so now let's move into Vue and D3, right? We're going to use some of these things together. So one of D3's greatest strengths is its ability to generate SVG content. So what is an SVG? SVG stands for Scalable Vector Graphics. It is technically a file that is simply made out of instructions for the computer to render. So if we have a bunch of points, we can create lines that attach these points together and give you a nice quality when printing large, because at any moment the computer will always just generate what it's supposed to look like. It's not like a raster image which is made out of pixels. This actually has different positions and typical math functions that go into it. Okay, so they're just like DOM elements. So SVGs are made out of multiple elements of objects or groups, just like our DOM elements. If we have a div element, we can put a header element in there, perhaps even put a span inside of the header element. So it's a way we can nest these elements, as well as different rules. We have different CSS rules that we can also use for SVGs. Different rules apply for certain elements. But either way, I mean, this is great because it meshes with Vue's template syntax perfectly, as well as being able to nest components inside of other components. So if we have, for example, the G element, which is a group element of an SVG, that's a container. We can have a container component that has other container components inside of it, and we can then kind of scaffold this thing down in a hierarchical fashion as well, if we wanted to. All right, so we'll set up our component to have an SVG element. So if you click open here, it should open up. Let's see here. All right, now we have our shape. It should have shapes component. All right, we'll get rid of all the other ones here. We're going to replace this button, so let's get rid of this. And instead, what we're going to do is we're going to put in an SVG element, right? So we're going to say SVG, and let's give it some attributes. We'll give it a width of 100% and a height of 100%, right? So we'll go ahead and we'll do that, and then we'll put in a little thing here that says, some content. So we'll put some content there eventually, right? But we'll make this template with an SVG of width and height, okay? So just that, pretty simple. Right, now if we save this, let's go back over here. Now we don't see anything, obviously. So let's add some other elements that SVGs offer. So there's the circle element. So a circle element is basically exactly what it says. There's 3 main attributes to a circle. There's CX, CY, and R. So CX and CY are for the positioning, and then R is for the radius. Okay, so let's add a circle in here. We're gonna say circle, right? And let's give it some values. We'll give it a radius of 10, and then we'll give it a CX position of, let's say, 200, and we'll give it a CY position of, let's say, 500, right? And we'll format that. So now if we render this out, let's save this and see what it looks like on the screen. We can see that we have a circle, right? So here's our circle, and it's placed in exactly that position. We have 200 and 500. Okay, so typical setup that you would normally do. You could also do this with regular DOM elements by applying, a method for returning like a new style of a component, right? Or nesting components themselves and giving them a computed property of a style. You can do any of these. All right, so let's render multiple points. Right, we're going to make an array of points, and for this array, we're going to then create a circle for every single one of them, and we'll do it inside of the SVG. Okay, so let's make our data object. All right, I'll say data, and we're going to return an object called points, and this points it'll be an array of objects with an X and Y. So for the first number, for the first point, we'll say, let's change the one that we have here, this 200 and 500. We'll make this the first point, right? So X is 200, Y is 500, okay? So once we do that, let's update this template here to then visually render whatever these points is going to be, okay? And so to do that, let's modify our circle. We're going to say circle, and then we're going to put in v4. And we're going to put in our item index. So for v4 item index in, and then we're going to pass in points, right? We also need to specify a key, and that's why I'm using index here. So the key is going to be index. And then let's format this a little bit. All right, so now we've added these two other attributes to the circle element. We have v4, it says item index and points, and then key is index, right? Okay, so now for each iteration, now we have item as the scope, and item is going to be the point, right? And so for each point, we have an x and a y. So we can keep the radius the same, but let's change cx and cy to represent the current items x and y. And to do that, all we do is make them, we bind them by using this, right? Same thing as doing vbind cx. And we're going to use item.x, right? Same thing with cy, we'll do item.y. Item.y, okay? So now if we do this, technically we won't see a difference visually, right? But if we go into our console here, and let me move this, I'll move this over to here so we can kind of see. If we go to our Vue tab, and we select our component, right? We have our, I believe it's shapes, something with shapes. Actually, let me make this a little bit smaller here. And we'll go into, here we go. So we have my component. These are the points that we've added, right? So this should represent every single one of our points. Now, if we move this, it should be reactive, whereas we can go like this, and now the value will automatically update in our SVG. Same thing with y. And we can also add other points. So we can say x is, I don't know if this will work in here. Let's try it. Let's try 600. I don't know if this will work or not. No. Okay, hold on. I'll just we'll do it inside of our console. So we'll say vm0.points, and then we'll push another point, and we're going to push x of 900, and we'll push a y of 200. Right. So if we do this, well, oh yeah, we do. We have it right here. Let's actually we'll move this out a little bit. We'll set it back. Okay. So you can see here that, you know, we're having Vue automatically render our SVG, and it's applying the values that our data objects are representing. In this case, we have 2 points. All right. So let's add some interactivity to this. We're going to make it so that when we click anywhere on our SVG, we're going to add a point, right? And we'll do something where when we right-click it, we'll make the entire array nothing, okay? So if we go over here to our component, let's add some functionality onto our SVG element. We'll say when we click it, so when we click anywhere in the SVG, we're going to call a function that says add point, right? And we'll just keep that as is, right? So we'll eventually have to add the add point later. And then we're going to add another one, and this will be for the right click, which is the same thing as context menu. But what we'll do is we'll prevent the context menu from appearing, and we'll make it so that when we do that, we'll say points equals an empty array again, okay? So once we do this, we just have to add a method called add point. So let's go back down here. We'll add a methods object. Inside methods, we're going to add an add point object, and EV is going to be our mouse event, right? And actually, we can say param mouse, no, say EV, and EV is going to be a mouse event, right? Okay. So let's get some information from this mouse event. So for each mouse event, we have 2 values. We're going to need to get our mouse positioning x and our y values, right? So let's destruct this event a little bit, and we're going to take a couple properties. We're going to take a layer x, right? We're going to rename that to x, and layer y, we'll rename that to y, right? So now these values here represent our mouse, the mouse x and y point, okay? Now that we have this, all we have to do is just add this to our original data set, our points here, right? So we can say this.points, right? We're going to push this new object, the new object being x and y, right? So let's see if when we click on the screen, what should happen is we should be able to get a new circle right where we click, like so. right? Therefore, allowing us to modify our points array and add these new values, right? And then Vue is going and it's creating these elements to represent our points array object, okay? And then if we right click, we make everything nothing again, therefore getting rid of these elements, right? So pretty straightforward. Okay, so now let's add another element. We're going to add the path element. So a path element takes in a string of drawing instructions and displays a shape off of that, right? Now, every shape has a path, okay? So a path element, we pass in an attribute called D, which is short for the path definition, okay? In order to get one of these paths, we need to somehow provide it with some instructions, okay? Now, fortunately for us, we have another helper of D3, which is D3 has a section called shapes, right? And so in the shapes, we have a ton of stuff, one of them being a line, right? A simple line, right? So we're going to work with D3 line. And what we're going to do is we're going to take each one of these points and we're going to display a line that connects all of them together, okay? So let's look at what D3 line is. So D3 line is it returns a method, just like scales, right? It returns a method. So what we want to do is we want to consider that when we create this reference to a line, we're going to call it a generator because it's going to be a method that we pass an array of points to, and it will give us back a string that represents the shape of that, okay? So we'll add it inside of our computed properties. We're going to say line generator. We could do line generator, that's fine. All right, now we're going to return back a D3 line instance, right? And then we're going to chain onto it, so it's going to be D3.line, and then we need to pass a couple properties to this. We're going to pass in an X. This is a method that will, for each item inside of the array that we send, it needs to know how to retrieve the X value of it, right? So for this example, we're passing in an item, and for each item, it's going to be the item's X property, right? We can do the same thing for Y, where we're passing in the item and we're returning the item's Y property, right? So now, whenever we pass an array of data, it's going to give us for each item the X and the Y value, and it will return back to us an actual string that will represent the instructions needed to pass to a path element, okay? So let's try this out. If we passed in we pass in an array of objects, right? So let's clean that up a little bit. Okay, so for computer, we have line generator. So let's say we have our circles. Let's separate our circles. We'll say circles are here, right? Now we're going to add in our lines. So let's we'll say for a single path, right? The path is going to be a path element. Right, path, and we're gonna say let's do a couple things here. We're gonna give it a fill equals we'll do transparent for now, right? Fill is transparent, and then we're gonna give it a stroke of let's say 1. We'll give it a stroke width of, actually, you know what? Sorry, stroke is the color, so we'll make it white. Stroke width. We'll make that 1, okay? And let's see, what else do we have to do to that? Oh, and then we have to assign its D attribute. So let's format this real quick. And then we're going to add in this D attribute. It's going to be a bound. And we're going to pass in our generator, right? And we have our points is going to be what we pass to the generator. So if we say line generator, and then points like this, right? What this will do is it'll give us back a string. And it just so happens that path looks for a string of commands to be able to send to this, okay? Let me see here. I think I messed up somewhere. Oh, I'm sorry. I need to add a reference to D3. Okay, so I don't have D3 in here. Let's import D3. So import star as D3. We're going to import everything from this D3 library. Okay, so import D3 from D3. All right, so let's save this out. We'll go back over here and see what happens. I might have to refresh. Let's refresh. Okay, so we have our 1 point, right? Now if we click it again, we should get now our path is going to follow the line that we are creating, right? That's all it takes. And if we inspect this, we can see that in the SVG we have a path, and the path's D attribute is a string. And these are instructions to create a line, okay? So just like that, you can easily make a way for you to do this. Now, another cool thing is that D3 line also offers a couple extra things. So here we're getting the X and the Y. That's great. But we can also get we can make it a curve. We can curve the line. So let's try this out. We're going to curve it, and we're just going to do a simple curve. We'll do a curve natural, let's say, right? So we did curve natural. Let's see what that would do, okay? Now when we draw, you can see that the line now has a curve to it, okay? And that's all it takes. So really, it's you know, applying these generators, we can do this stuff. As a matter of fact, now because it's a computer property, if we had, let's say, some we wanted to specify like when or what curve do we want to use, if this value is mapped to like some other object, let's say a value in our data object, then this will then update itself whenever that changes. Okay, and you can see in a good example of this. And by the way, you can control click on any of these lessons, and it should show you the finished equivalent. Okay, so for here, I added some extra things. These are all of the curves that you have available, right? So let's draw. We'll draw some lines. We'll do this. Okay, so this is curve linear. Now, if we wanted to look at it with curve basis, we can see that it does things differently, right? Each one of these lines or curves, they can represent something different, right? We have curve monotone X, curve monotone Y, natural, curve step after or before, right? So each one of these things, you know, they show a curve in a different way. There's also, you know, parameters that you can send to it. Like, for example, a curve bundle, which it will always attach the first and the last items, but then give you this sort of curve for each one of its steps. But you have a way to change the strength of it, I guess you could say, right? I forget what that's called. But you can see that just by having that method as a computed property that's reactive to what you send into it, you can really, you know, change this to however you want. All right, so moving on, we'll go into layouts now. All right, so we've kind of covered being able to, you know, create an SVG. The SVG is being populated by Vue, and its attributes are being set based off of the values that D3 is computing, right? So it's a pretty simple setup. Let's go into layouts. So with layouts, there's multiple layouts that that you can for using to display hierarchies, and the D3 hierarchy library offers these layouts. Now these include clusters, trees, tree maps, partitions, and packs. Okay, pack being a circle pack. Now tree map and pack, they both have a nested display, meaning they do not show links connecting nodes. Instead, they represent the hierarchy by fitting their descendants within the same space as themselves, okay? So going back to the examples, if we looked at the examples here, this is showing a line that connects one node to the other, right? But something like this does not, right? It doesn't show links of the descendants. It uses its space in order to put these descendants inside, okay? So this is for tree maps. Same thing with circle packs, okay? So for this circle pack, you can see there's no line that connects its parent to its children. the children are inside of the parent, right? That's how we can visually display it, okay? All right, so going back over to here. So since they don't show it, instead, represent it by fitting the descendants in the same space, we can use these to create a number of layouts like the ones shown, right? They expect a hierarchy instance to be passed, and they simply assign more properties to each node for position and size. So like we did before where we summarized the hierarchy, that added a property onto each node called value, right, and gave it a value. It's the same approach. With layouts, when you pass a hierarchy to a layout, the layout will do whatever calculations it needs to do, and it will apply more values to each node, right? So we have value for each node. If we added a layout, let's say a Circlepacking layout, that will assign each node a couple different properties. It will have a radius value to it, and it will also have a x and a y position value to it as well, right? So the way that these layout works is just like that. Okay, another thing, it's fully reactive, right? So in our setup, right, what we can do is we can set this up in a way where whenever we change properties, like let's say the padding of the layout or the width and height of the layout, or other properties that these layouts you can give these layouts, what we'll do is we'll make it so that Vue will kind of look out for this stuff, right, in a smart way, and if anything changes, have it rerun the layout on these objects. And because these objects are reactive, our layout will automatically update visually. Okay. All right. So let's try this out. Let's open this up. All right, we're going to open it up in here. This is our fresh layout component. Okay. And we're going to kind of do the same thing where we set up an SVG. We're going to say SVG width equals 100%, height is 100%, right? Put content in here, clean that up. Okay, so we've got our SVG, we have our content here. We need to assign some properties to our data object, right? So let's get our data object kind of set up, right? So we can say data, so we're going to return a width property. We'll just set it as 100. Say height property of 100, and we'll give it a padding. We'll say padding of 2. And by the way, we're going to do a Circlepacking layout, so padding actually applies. Let's see, what's another one? H. So we'll assign H to be a hierarchy instance by default, like that. And let's import D3 too before I forget. Start as D3 from D3. Okay, so we got our hierarchy, all right? And then after H, we also have the grouping order. So what we're going to do is we're going to visualize a data set of the entire world population, right? And we're going to do it in a Circlepacking layout. So for the group order, in the data set, you have, for each item has a region and a subregion, as well as its population count, okay? So what we'll do is we're going to apply a group order object, and this is going to be an array, and we're going to make it region, subregion, right? And we'll get to this part in a little bit, okay? We're going to add something to the computed properties that kind of make this thing kind of cool. All right, so we have group order, and then we have one last one, which is data set, right? So we'll make that an empty array. All right, so let's look. We have width, height, padding, group order, and data set. All right. Sorry, my kid's like crying in the background, so I'm trying to. Okay. All right, so we've got our data. Now let's create some methods. So each layout, we need some type of size in order to perform its calculation for scaling and positioning, right? Now we have our width and our height, and we can apply that, right? But we want this to resemble. We want this to always equal the size of our actual element on the screen, right? So our first method that we're going to create is going to be called update size, right? So we're going to add update size, And what we'll do is we're going to get the width and height of our element and assign it to the width and height objects in our data, right? So let's get that information. We're going to say equals this.el .getBounding client rect, right? So inside here, we're going to have a width and height. Okay, so we have width and height, and we're going to assign this to our properties, right? So we've got this.width, it's going to equal width. This.height is going to equal height, right? So now if we do this, update size should automatically change it so that our component will it will look for this new size and apply this whenever we call this method. Okay. All right. So the next thing is that we want to load some information. We assign the sizes. We'll load some data, and then we'll assign this data to our data set. Okay. So let's add another object. We're going to say mounted, right? So for mounted, and one other thing is we're going to make it asynchronous. So we're going to say async mounted. All right. We're going to do 3 different steps. We're going to say 1, update the size, right? And then 2, we're going to load our data. And then 3, we're going to apply a frozen, let's see. We're going to apply the data as read-only to our data set, right? So for updating the size, we simply just call it this.update size. And then for loading the data, we're going to say const data equals await, and it's going to be D3.json. And we're going to load in, we have data sets, and then we have populations, I believe. So populations.json, right? So data is going to load this. And then we're going to say, for number 3, we then apply this data to our data set. So we'll say this.dataset, and we're going to equal a frozen version of data, right? So once it's mounted, let me move this up a little bit. All right. So when it's mounted, we're going to update the size, load the data. Once the data is loaded, we then apply it to this data set, right? So when we save this out, all right, when we go over to our component here, we navigate over to Vue, go to my component. We can see that we have our data set, which has 229 different items. We have our group order, and we have our hierarchy. We have height, padding, and width. Okay, so we have everything. Everything's loaded in, and we're getting it all correctly. Okay. Okay. All right. So now, let's add some of these computed properties, and this is kind of where it makes everything really cool. All right. So there's a certain order that we have to do this in. Okay, and there's certain properties that we're going to make computed. Okay. And there's a couple reasons for this, right? We're going to be making, well, let's first create the computed property. All right. And before I do that, let me just double check something here. Why, I'm sorry, I'm trying to answer a question. Why minus and not less than? I don't know what that was referring to. Yeah, I apologize. I'm sorry. All right, so let's do this. We have some computed props. We're gonna have a layout computer property. We're also gonna have a nester, right? A computer property, which is the nest object that D3 offers. And then we're also gonna have the nested data, right? So we have 3 main computed properties that will update whenever certain values change. And then we're going to have some watchers that will watch these properties and assign certain things, right? Okay. So for the first thing, we're going to say the layout, which is a method, right? And we're going to say the layout is going to be, in this example, we're going to do Circlepacking, right? So we'll say layout, and we're going to return D3.pack, all right? So it's a packing layout. Let's give it some properties. So like size, for example, size is going to represent our size, which is this dot width, this dot height, this dot height. Okay, so there's our size. We'll add padding. Let's add padding. Padding will be this dot padding, right? Okay, so this means that this layout is going to return a function that will call. However, this function will always change if this changes, if width changes here, if height changes, if padding changes. Okay, so we've made a layout reactive. All right, so let's do the next one. We need to create a nester, right? So we'll call this nester, and this is going to return a okay, so this is going to return a D3 nest object, okay? But this is going to change depending on our group order values, okay? So to do this, we're gonna create a variable that represents our D3 nest, all right? And then what we're going to do is we're going to loop through our group order, right? So group order dot for each. So each of our grouping orders, the value of the order, right? So in this example, we have, let's see, our order by default is region and subregion, right? So we want to make keys that will group our data set by that, in that order, okay? So for each one of these group orders, we're going to apply a key to the end value, right? So we're going to say key. And then for the node, we're gonna say node, and then we're gonna pass in what the value would be for each of these groups, right? So it's gonna say, okay, for each one we have region and subregion. So it's gonna add a key where it's gonna look for the node's region, and then another key for the node's subregion, right? So now when group order changes, this new nester object will automatically update as well. Right? All right, so now let's add another one. And this is going to be our nested data, okay? And nested data will actually change when either our data set changes or our new computed property nester changes, right? And so this just represents our new data that we would apply to a hierarchy, right? So we'll say nested data, right? And we're going to return, and this is always going to be the root of everything, right? It's going to have a key value of root, right? And its children is values, and the values is going to be this dot nester dot entries, this dot data set. Okay? So technically this should work. Now, there's a couple things that we need to do. We need to observe some of these computed properties, but then we need to recalculate everything. And in this case, these are like side effects, right? So we don't want them to be computed properties, okay? So let's do a couple of them. We're gonna watch for the layout property. So when the layout property changes, we will apply it to our hierarchy, meaning that if the layout method is changed in some way, let's reapply it to our current layout. I'm sorry, to our current hierarchy. Okay. So the first thing is let's add the watcher, watch object. All right. So in watch, we're going to add layout. Right. So when layout changes, we're going to call our layout to be run on our hierarchy. Right. Let's move this up. Okay, so under watch we have layout. So this will change when layout changes, reapply it to our hierarchy, right? Now, the last one for watching, we have to watch when nested data changes. When nested data changes, we need to recreate our hierarchy and then also apply this layout, right? As well as doing some other things. We have to summarize and sort the values, and then we have to run the layout after we've done that. So it's, we have to do a couple of things. So let's watch for nested data this time, okay? So we'll say nested data. So when nested data changes, and I guess we could just use val. So val will be the new nested data representation, I guess. Okay, so let's make a new hierarchy. We're going to say D3.hierarchy. Oops. D3.hierarchy. Right? We're going to pass in val, which is our new data. And the method of retrieving the children is going to be finding the values property. So it's going to be v.values. Right? So H is going to be our hierarchy. We're passing in this as our data, and we're going to find all of the options based off of the values property of each layout, right? And this is nested data. Okay, so got that. Now we have to summarize it, right? So let's do h.sum. We're going to summarize these values based on the value of these nodes, right? So let's just apply value. Okay. And then let's sort it too. So we'll say h.sort AB, and then we're going to say D3.ascending, and then it's going to be A.value, B.value, right? Now that should work. Let's see here. Okay, so first, so we create it, we summarize it, and then we sort it. Now after we've done all this, now we can apply the layout. So we'll say this.layout of H, right? So this will mutate layout again. And then all we have to do this time now is we just say this.h equals h, right? We're assigning our observed hierarchy object. We're going to make it equal this new one that we've just constructed up, right? Every time nested data changes. So now at this point, everything is observed. It will calculate things in an order that just it works, okay? So let's render it out. Now this is a circle packing layout, which means that it's giving us an x value, a y value, and a radius, okay? And actually, if we look at this, right, let's try this out and see what happens, make sure nothing blows up. All right, we'll refresh just in case. Okay, now we have our component. Now let's inspect this component, and let's look at our H object here. We can see that we have this R value, we have this X value, and this Y value, right? I'm not sure why. Let me see here, nested data. Oh, I must have done something wrong with nested data. Let's see. I think I messed up somewhere. Let me see here. Use root. Values is going to be the entries of this data set. Oh, I see here. So I did not return the nestor object, so let's return n. I think that'll fix everything up. Okay, let's try this again. So if we look at our H object, we have R, X, and Y. So we're getting values already, right? So let's render this. These are all circles now, right? And so if we go up to our template, we're going to create some circles, right? So we're going to create circle, right? Let's loop through these. We're going to say circle v4 equals, and then we'll say item index in, and then we need to pass in all of the nodes. And the way to do that is we can say h.descendants, right? And it's a function. So we'll say for each item in the descendants, the key is going to be the index, right? And then a couple other properties. So let's add these in. So we need our radius, right? So r equals, and then we're going to say item.r, right? Let's add another one. We're going to add our cx, so it's going to get our x position. Let's get item.x. And then our cy position, which would be item.y, right? So now if we do this right, let's see what that looks like, okay? So we'll save this out. Let's go to our display here, and we might need to refresh. Let's refresh it real quick. Okay, so now we have a circle packing layout, right? Each one of these things is a circle element, and it's being positioned and sized just like how the layout. But the cool part of this is that all of these values now, they're reactive, right? So if I wanted to add padding, I could do so, and everything will update just as I want, right? Another thing too is that we are viewing each one of these items, right? They represent, something that's inside of our data set. The size is based on value, but see, we are grouping them in a certain. We are able to construct the hierarchy, right? What we're doing is we're grouping things by their region, and then we're grouping things by their subregion. Well, what if we just want to group things by their region, right, or subregion? Let's say let's get rid of region. Let's just group everything by their subregion. If we do that, it will re-update the hierarchy, right, by applying another nesting method. And then because of that, the layout will then, it'll watch for the layout to change. The layout will then update and apply this, and it just works, right? Every part of this works. Even if we change the data set, it would work. Let's do it without any sort of grouping orders at all. We just have them just as by default, right? This will rearrange our structure to make it look a little bit different. We can get rid of subregion. And now we can see that there's no parents. We just have the root of everything. And then the root would have children. And it's organized in a way where the smallest ones are towards the center, right? Still same concept. We can change the padding. We can even modify it so that we can say em0.grouping order equals just the region, right? So now everything is ordered by the region. So this is great. And we can do this with any other layouts. All right, so let's do something. What we'll do, let's take a quick break, okay? And we'll look at all this stuff. You guys can play around with this stuff. We'll take a quick break, and then we'll come back and we'll switch it from, instead of being a circle packing layout, we'll make a dendrogram so that we can render these lines that connect the nodes together, okay? So let's go back in about 10 minutes or so. I'm going to put my timer on. Let's do 20 minutes, and then we'll come back. All right, and we're back. So to finish this up, we went through the layouts. We made a circle packing layout. So let's go here. Let's take a look at it. Here's our layout that we had made. All right, we went through each of these steps. So the one thing that we didn't do was being able to render these links. Now, this circle packing layout doesn't really need that. So what we need to do is we need to change this to something else, and then we're going to render these links associated to it. So the best way, let's change this pack layout. We'll change it to a cluster layout instead. Now, since the logic that's involved, it really it works well with all different types of layouts. All we really need to do is focus on changing what type of layout we're going to do. So instead of making the pack layout, we're going to change that to be a cluster layout, right? So with the cluster layout, there's a couple of things that we don't need anymore. In this case, we don't need in our data object. We don't need padding, right? So that's out of the picture. Okay, so we can get rid of padding altogether. And then for the layout here, go to pack, and we're going to change this to cluster instead. All right, so we're going to change this to cluster, like so. Okay, and it still needs a size, but we don't need to give it a padding this time. Okay, so whenever our width or height changes, then this should change out as well. Okay. So when we do this, everything else will work just as expected, and we'll apply the layout to our hierarchy. But instead of our layout assigning the positioning and the radius for each circle, what it's going to do is it's going to assign positioning for our nodes, all right? But our nodes are going to have the same radius. Okay, so first and foremost, after we change this layout, all right, our layout is going to provide our hierarchy with the same X and the same Y. but it's not going to have an R property to it because we don't need. It's not going to give us any size based on it's not going to give us a radius. We don't need it for this kind of layout. All right, so let's go up here, and instead of making R a bound property of the item, we will just make it 5. Okay. Now the items X and the items Y is still valid because the pack layout, it applies X and Y properties to our hierarchy. So does cluster, and same with like the tree layout, for example, right? So if we do this, what we should be able to see, if we save this out and look at our new hierarchy, right, is that we will see, and let me refresh this. We're going to see a new layout, right? Now we have all of our nodes still, but now the X and the Y positions have changed, right? And it's showing us in this sort of node link node fashion, right? Okay, so what's missing here is the links. Okay, now we already have I believe we might have a line generator. No, we don't. Okay, so to add these links, all we have to do is create a line generator function. The same thing that we did when we were creating shapes within our SVG. And this will be another generator. So let's go ahead and add that. Right? So we have our layout as a computed property, of Nestor as a computed property, nested data. Let's also add in a line generator. Okay, so we'll say line generator. And we're going to return a D3 line instance, just like we did before. And we're going to assign our X and Y values to be the same methods that we did in shape, because for the data set that we're passing into, each item is going to have an X and a Y property, right? So for this, we're going to say item.x, right? And we'll do the same thing with Y. We'll say item.y, right? Now we don't need to assign a curve or anything at this point. We could do that later. But for now, as long as we pass in an array of points, this will give us a valid line attribute, right? So we've added our circles. We'll comment it here. We'll say circles or nodes, right? And then for this one here, we'll say paths, or let's call them links. Okay, so these are going to be links, and we're going to loop through each one of our links. But we're going to make a path element. So the path, we're going to say that, and then we're going to say before equals, and then we're going to say for each, actually let's call this link, and then we'll say index. Okay, so for v4 link index in, and then we'll say h.links, right? So instead of descendants, we're going to say in h.links. This is going to give us back an array of objects, and within these objects are links. So within each link, we have a source and a target, and these are both nodes that have an X and a Y value, right? So for link index and h.links, we'll give it a key of index. Actually, let me take that back. To note, just to show you guys here. So if I have this going here, right? The key is going to be 0, 1, 2, 3, 4, and so on. If I make this key to be index as well, we're going to have a problem because there's going to be multiple keys that that can conflict with each other. So instead of me assigning the index to the links key, let's just change this and make it so that we have we'll say links underscore, and then we'll put in the index like that. Okay. So this will have a key of links underscore index, whereas this will just have the index. Okay. Okay. So now we've done this, right? We'll end that and let's reformat it. So this needs a couple of things. Well, actually, no. It only needs one thing. So we have our line generator function that will give us back a path. That function is expecting us to give it an array of objects, whereas each object has an X property and a Y property, right? Based of the generator function we created. So if we did this, all we would have to do is pass in the source and the target object, right, inside of an array. And we can do that by just saying that the D attribute is going to be an array, and I'm sorry, it's going to be our line generator. And we're going to pass in an array, and the array is going to be our links source, right? And the links target. And let me change links to link here, right? The link source, link target. Okay, so what this should do now, let's save this out. Let's see what happens, okay? We should be able to get a line that represents each connection to each node. See that? Right, and it's as simple as that. You know, we have, we're passing in links for each link. Each one is an array with 2 items, the source and the target. We are then applying our line generator to that, giving us a connection between the strings, right? And the same thing goes where everything is reactive. We can get rid of, change the grouping order around. If I remove this, you can see that it changes, right? You can see if I change this completely, you can see that they're all leaf nodes at the very bottom. They're all connected to the root. So everything is reactive. Same thing goes with the width and the height. We can change the width and the height to be whatever. So if we add, you know, a little window event listener or a resize observer, we can then update the width and height and have this thing automatically calculate. Okay. All right. So the next step here, you know, to be able to easily change these things out is great. But there's other ways that we can display some stuff, right? This is a dendrogram. But let's see what we can do as far as applying a radial layout to this, right? So a radial layout, you know, it would start from the center, the root being the center, and then these things would kind of protrude out. So how do we take something that's like this and convert it into that kind of format, right? So let's go to radial layouts. We can apply simple trigonometry to do this. So the math involved is, in order to get the x and the y values of a rotation, we need the angle, and then we need the radius, right? So in degrees, a full circle is 360. However, we'll be working with radians to determine the angle. Now, so in a full circle, it's 360 degrees. So the same equivalent in radians is 2 pi. So it's pi times 2, right? Or 6.28315, blah, 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 blah. Another thing to note is that when displaying a circular layout, the center point, or the origin point, I should say, it needs to be in the exact center, right? It can't be at the top left, because then you're going to see, you know, things are going to go off the screen because they're going to go into negative values. So we're going to add a couple of computed properties, right? We're going to add our radius, which is going to find the minimum number between our width and height, and divide it by 2, right? That way we're always sure that it will fit a circle within the area provided. Another one is we're going to apply center. And center will just be the center point of our dimensions of the element, right? So it's basically the width and the height divided by 2. So let's go ahead and do that. So we'll open this up. All right, now we have our component here. One thing to note is when we remove this button here, what we're going to get is we're going to get exactly what we just created, right? We should get what we just created. Let's see here. We have our nested data. We have our nester. Let's take a look at this guy and see what's going on here. Interesting. All right, it's not showing up. Let me see what's going on here. Let's get rid of. Okay. Hopefully that'll work. There we go. Okay. All right, so now we have it's exactly where we started from, right? We're going to turn this into a radial layout, right? First thing is, let's apply some of these computer properties. We're going to add the radius in the center. All right, so let's go to our computed. All right, we have our layout, we have our line generator, we have our nester, we have our nested data. So let's add some of these. We're going to add radius, and radius is going to return back the minimum, right, of our dimensions, right? So it's going to be this dot width. Pass in both of these here, right? So it's going to find the minimum value between width and height, and then we're going to multiply it by 0.5, right? So that'll give us our the radius that we need, right? Okay, and then the next one is that we need to have a center point or an origin point, and this is going to be our width and height, but half, right? Half width, half height. That'll give us our center. So we'll return a new object, x being this dot width times 0.5. Right? Y being this dot height times 0.5. Okay. All right. So now we have our radius and we have our center. All right. Now to convert these values, we're passing into this layout. We're passing in a size, right? And the size is our width and height. So by looking at this, the width can represent the angle, right? In which if this is 0 and this is 2 pi, then it'll do a complete circular rotation, right? And then the height, which is the y position, would represent the radius, right? So if this is right dead center, which is technically pi, right? We need to multiply it by a radius that gives us that's the y value, right? All right, so let's go ahead and do that. Instead of applying height to our layout, instead of applying the dimensions of our element to the layout, right, we're going to go into our computed properties. We're going to go to our layout, and instead of doing this dot width and this dot height, we're going to say the width is going to be, and we can keep the well, we're going to change a couple of things here. We're going to say for the layout, the beginning part, it's going to be math.pi times 2, right? So that's the full size, math.pi times 2 for our layout. And then the height is going to be our radius, right? This dot radius. That's the maximum height, right? This gives us a new way of displaying this stuff. Now, it's not going to show up nicely when we display it here. So if I, hit save, this probably won't turn out that well. It'll probably look like a little line here. This gives us our radius. The height is radius, but we don't really see a lot here, right? Okay, so to convert the x and y values, we use sine and cosine. So we'll write a couple of functions that will convert, an x point, which is going to be our angle in radians, and convert it to an actual position on the screen. And we need to do this by passing in both the angle and the radius. All right, so we'll write a couple functions here. So instead of methods, all right, we have update size. Let's add some other ones. We're going to say 2x point, and we're going to return back math.cosine, right? Cosine is x, by the way. And we pass in the angle in radians, which in this case it's point.x, right? And then once we do that, we multiply it by the radius, right? So point.y is the radius. So that's our 2x. And we can do the same thing with y by applying a y property or y method to y method. But instead of cosine, we're going to use sine, right? And it's the same stuff that we're passing. We're passing in the angle, we're passing in the radius, okay? So now that we have these two values, right, we can technically take each one of these points and convert it to the correct x and y positioning, okay? But there is one thing that we need to do, and that is that we need to add the offset to display it from the center, right? So we'll go back up to here, to our template, and if we look at our cx and our cy for our circles, we're just getting the item x and the item y, right? So instead of this, let's offset it first. So we're going to say center.x, and then we're going to add, and And then instead of the item's x, we're going to convert that to actual x and y like positioning by passing in this item, right? So if we say to x, we get rid of that, right? Because the item is going to have our angle and the radius, right? So we're going to add the x point, I'm sorry, the center point, and then we're going to adjust it to then apply its new radial position, okay? We're going to do the same thing with item y. We're going to say center.y plus, and then we'll say to_y item. All right. Now, if we did this correctly, what we should be able to see is we'll see our circles in the format that they should be, and you might have to refresh for this. All right. So now we see a radial version. Right. We're taking the x and y values and we are repositioning the nodes to be in the correct place, right? So this is great. The only thing that we have to do now is we have to change it so that each one of these links will now represent that same approach, right? And it's as simple as just converting to the x and y based off of the angle and the radius using sine and cosine, all right? Okay, so for the line, technically, we can do it by just modifying the line generator function, right? So now, the line generator function currently just retrieves the x and the y values from each node. So that's obviously not going to work for the positioning that we want it. So what we'll do is we'll rewrite it a little bit by adding the offset and then also applying sine and cosine to these values to get us a valid x and y position, okay? So let's try that out. We'll go to our line generator and we'll say return d3.line, which is fine. And now the x and the y properties are going to be a little bit different. So instead of just returning the x, we need to return the offset, right, plus the x version of this, right, the x angle, I guess you could say. So what we'll do is we'll return this.center.x, right, and then we're going to take this guy and we're going to convert it. We're going to convert it to the real x coordinate by using cosine, right? We're gonna do this by passing in the angle and then multiplying it by the radius, right? So what we'll do is we'll take this guy. Let's put in some parentheses. We're going to say math.cosine, right? Now each one of these things, this v here represents a node, and a node has an x and a y. So in this case, the node's x is the angle and the y is the radius. So if we put a cosine of the angle, right, which is v dot angle, like so, right, and we multiply it by v, I'm sorry, not angle, x, right, and we multiply it by v dot y, right, this will give us the correct positioning for the x. So now let's do this the same for this. We'll say this.center.y plus, and then we'll say math.sine, pass in the same stuff, v.x, right? That's our angle. Multiply it by v.y, right? Okay, so now by doing this, right, we've changed it so that it's now going to give us the right coordinates. Okay, so let's save this and let's see what happens. All right, so now we have our lines to represent our angles correctly. It's positioning everything correctly. And all we did was assign the width and height to then act as like the angle in radians and the radius, okay? And that's pretty much it. Now, one thing to note is that D3 does offer radial variants of its generators. So we have a D3.line, but we also have D3.line radial. We also have point radial, and they do the same job. I mean, you pass in, a point that has an angle and a radius, and it'll convert that to, I don't know what exactly the equivalent is, but it does the same thing, right? So I wanted to go over that using the sine and cosine stuff, because if you have a good understanding of that, you can do a lot of things, especially with doing radial layouts, right? So that's pretty much it. You can hold Control and click to see any of these other ones that were created. You can see here this will automatically update there. This is the same thing here. That's pretty much it. So I hope you guys enjoyed this, and thanks again, Vue.js, for giving me the opportunity to do this. I will go ahead and update this video. I'll get rid of some of the cuts. I'll clean up my audio a little bit, and then I'll have this so we can archive it. So please enjoy it, and if you have any questions, feel free to reach out. I'm here as much as I can be. All right, well, thanks all. That's the end of the stream. And let's do some Vue and D3, guys.